Hello, everyone, and welcome to Chapter 1, Section 1 of Algebra 1. Your book should look like my book. This is the textbook that we will use throughout this course. For this video, I'm going to introduce you to Chapter 1, Introduction to Algebra. We will only cover Section 1 in this video. My concept behind the videos is to walk you through the information that you should have already read and make sure that you have a couple of practice problems under your belt before you start your homework. You'll always be able to find the assignment on your Easy Class module. Just click on the assignment link and you'll see the problems that you're responsible for each section. The best way for you to complete the section is paper pencil yourself. And when you are finished, just take a picture of your finished product and email that back to me at choicelearningonlineacademy@gmail.com. And I'll be able to grade your assignment and then get you back your score. If at any time throughout the week you have a question about a problem or something I said seems confusing, you can do one of two things. You can put your question out on the discussion post so that your peers can also chat it over and you can help each other in that way. And then you can also always reach out to me. I can be available to help you throughout the week as you are working through your assigned problems. Each of these videos will be pretty short. I like to keep them under 10 minutes. I'll do a video for each section, so we will only cover 1.1 in this video today. Let's go ahead and get started. You'll see that I use a whiteboard often when I'm working through the problems, and this is a way for you to sort of leave our lesson with some of your homework already completed. I'll be doing a handful of problems for you today. So if you start on page 2, the very first thing that we're going to discuss is this whole concept of using multiplication in algebra. It's a little bit different than using multiplication in arithmetic. When you use multiplication in algebra, you're no longer going to use the old school times sign. So for example, maybe in arithmetic you had a problem that looked like this: 2 times 5, and obviously the product here is 10. We're not going to use this x to represent multiplication anymore because we'll be using variables and that could be very tricky. Instead, we're going to do some things like this raised dot. This would stand for multiplication, and we're also going to incorporate parentheses. So if I said 2 and then I put 5 into parentheses, it would mean the same thing. It would still stand for multiplication. So you're not going to see the old school multiplication sign anymore. Instead, you're going to see the raised dot or the parentheses. Now, how does that impact your first couple of problems? Well, let's just look at number 1 together. So here's your first freebie. The directions for number 1 says indicate multiplication using parentheses and then without using a raised dot or parentheses. So the first problem they give you is 5, this raised dot that stands for multiplication, times s. 5 multiplied by s. And in algebra, we're going to start to use variables, which are letters that stand for unknown numbers quite often. But for number 1, all we need to do is just rewrite this problem and demonstrate that we understand how to show a multiplication problem. So we could say 5 parentheses s, and this is a valid answer. This says the same thing, 5 multiplied by the value known as s. Or we can just completely drop the parentheses altogether and just say 5s. Anytime that you see a numeric coefficient, which we'll describe here in a few minutes, which is just a number, in front of a variable, which is an unknown, usually represented by a letter, then it means a multiplication. That's what it means. It means multiplication. We just don't use this old school multiplication sign anymore because it can look a whole lot like the variable x. So if you see 5 and s together, it means 5 multiplied by s. And these two are your answers for number 1. Let's do another one together. We'll jump over and do problem 5. The directions are the same. This is a little bit more complicated. We have 2 raised dot x to the second power raised dot y to the third power. Now, let's go over a couple of these things real quickly. So this x and this y, these are both called variables. Again, they are unknown quantities. And these little numbers up here are called exponents. And they describe the power that these variables are raised to. I'll go over that here in a few more minutes, but I just want to add these words as we move along through the lesson. So if I'm going to follow the directions and indicate this multiplication problem with parentheses, it would look like this: 2 times x to the second power, which is also called x squared, times y to the third power. So I could use my parentheses, 2, and then put x squared in parentheses, y cubed in parentheses, and this is one of our answers. That demonstrates multiplication with parentheses. Now let's demonstrate multiplication without parentheses. So I have the same set of information. I'm just simply removing the parentheses. Because remember, we discussed earlier that anytime you see a numeric expression like the 2 next to your variables, it is understood now in algebra that it's just a multiplication problem. So these are your two answers for 1 and 5. Let's sort of keep moving along through our section here. Let's talk about what we label or what we call parts of an algebraic expression. So there's an example at the top of page 3 that says 3x plus 2. And we start to identify the parts of this algebraic expression. The first thing that you're going to realize is that this number in front of the variable is called a numeric coefficient. A numeric coefficient. I'm going to abbreviate these for time. You can see the full word on page 3 of your textbook. And this is any number that is attached to an unknown number or a variable, which is what x is in this case. X is a variable. It's not the multiplication sign. It's a variable. It's an unknown thing that we must solve for in this problem. Another thing that you want to realize in this situation is that this and this, each of these components are their own term. So this is a term in this algebraic expression, and this is also a term in this algebraic expression. And you might say to yourself, well, how do I know what separates a term? Well, what separates it is this math sign. So addition can separate it, subtraction, division, multiplication. These can all separate your terms, but it's just basically a term is a part of a problem. So if we want to jump back into our set of problems for today, let's go into number 9. The directions for number 9 says identify the numeric coefficients and the number of terms in each expression. So here's a freebie for you, number 9. It says 12 multiplied by x and y, all divided by 22. Now, just so that we are clear on all this, I know that I said division can divide out your terms, but this one is all together. Because if I knew what the value was for x, and if I knew what the value was for y, I could turn this all into just one simple number or one simple value. So this is just one term. This is just one term here. So that kind of covers the term part, but it says identify the numeric coefficients, the numeric coefficients. And in this case, the only number that is attached to variables is this 12. So the numeric coefficient in this case is the number 12. 22 is not a numeric coefficient because it's not attached to an unknown. It does not have a variable that is attached to it. We don't say 22x. It's just 22. So it's just a number. It's not a numeric coefficient. So your answer for number 9 is one term, and the numeric coefficient is the number 12. Let's solve another one. We will also solve number 18 from this group. 18 is a little bit more complicated, so let's look here. It says 3 multiplied by q plus 8 subtracted by y divided by z, that quantity y divided by z, added to the quantity of 4 multiplied by v plus 3. So I want you to stay with me a little bit on this one. Again, we're identifying the numeric coefficients. So I'll kind of start this list here. And then we're also identifying how many terms there are in this problem. Sometimes it's easier to start with terms. So I'm just going to look here. This is one big group. This is a group. And this is a group. And so you can see that they are separated by this addition sign and by the subtraction sign. So here's term 1. Here's term 2, and here's term 3. So I can sort of go ahead and jump into this and say there are 3 terms and finish that portion of the problem. Now, the numeric coefficients can be a little bit tricky. Let's talk about what would make it tricky. First off, anytime that you have a variable, like say, for example, this q has an understood 1 in front of it. Let's say that the value of q was 5. I'm just choosing a number here. Then I could say 1 times 5 is still indeed 5. So when you see an unknown or a variable, it is always understood that the coefficient is 1. So again, here I have a y. I have 1y, so I can put my coefficient of 1 here. I can do the same thing for z. Let's say z was the value of 20. Well, z representing 20 or 1 times 20 is still the same thing. And then we have the last variable over here with v. And again, the coefficient is 1. So as we're looking at coefficients, this number 3 has an impact on this coefficient q. So it is a coefficient on this variable q. I'm sorry. 1 is a coefficient. 8, on the other hand, is not a coefficient because it's not attached to a variable in any way. If we were to factor out 3 times 8, it would just give us a number value, and it's, again, not attached to a variable. So we can move on. 1 is a coefficient of y. 1 is a coefficient of z. And then 4 has an impact on v, so it's also a coefficient. And the last coefficient is the 1 that represents the v. So your list of coefficients, numeric coefficients for this problem, 3, 1, 1, 1, 4, 1. And you need to list all of these ones because they represent different variables. And then again, we've already decided that there are 3 terms. Okay, we're trucking right along. So let's keep moving. Now we're going to go into the next section, and the directions here for this next section says identify the base and the exponent in each expression. So I want to jump over to some exponents. Let's say that we have 2 raised to the second power. This is an this is an arithmetic problem. You probably saw this a lot throughout middle school. And what this means is 2 multiplied, I'll use a raised dot to get into the habit of it, 2 multiplied by itself 2 times. If this would have been a 3, then we would have had a third 2 out here next to itself. So if I have 2 raised to the third power, then I'll have 2 times 2 times 2. And if I put this into my calculator, if I started solving, 2 times 2 is 4, multiplied by another 2, I discover that my final answer here is 8. And that's how we do exponents, or powers, as they're sometimes called. Here, when we start talking about algebra as it relates to these exponents, maybe we're going to have something that looks like this: x raised to the 4th power. And you have a chart on page 4 that helps to explain this a little bit better. But what this means is x times itself 4 times, because that's the power to which it has been raised. And this is what it means. So if x had a value of 2, then it would turn into 2 to the 4th power, and the value of x can change. So when we start talking about identifying the bases and the exponents, this big either number or variable is the base. So if we went back to our example of 2 raised to the 3rd power, this 2 is the base. And then, of course, that leaves this smaller digit as the exponent. And it is the same case down here. This is also the exponent. So the larger value, whether it's a variable or it's just an actual digit, is the base. And the smaller number that's represented in the top right-hand corner is considered the exponent. So let's jump into a couple more problems. We want to look at problem number 20. Number 20 says, identify the bases and the exponents in each expression. And the problem states 3 times x cubed times y squared times z. Now, but before we get started, one thing that we need to point out for sure is that anytime you don't see any exponent whatsoever, we know that it's actually raised to the 1st power. So let's just pull this 3 out and isolate it. 3 by itself is just a 3. 3 raised to the 1st power is just 3 times itself 1 time, which also happens to be a 3. So 3 to the 1st is the exact same thing as just the 3 itself. Okay, let's do the same thing for z. z to the first is the exact same thing as a z itself. But when we're trying to decide bases and exponents, it just makes a lot more sense to go ahead and stick those invisible ones up into our problem so that they stand out. So let's make a list of bases and exponents, and I'll just abbreviate it with EX, and I won't make base plural. Okay, so our first base is a 3, and the exponent that belongs to that base is a 1. Put in our commas so we separate. Our next base is an X, and the exponent that belongs to that X is a 3. The next base is a Y, and the exponent that belongs to that Y is a 2. And the next base is a Z, and the exponent that belongs to that Z is a 1. So your bases are 3, X, Y, Z, and your exponents that correspond to those bases are 1, 3, 2, and 1. Okay, that hopefully makes pretty good sense to you. So you will be solving through 1 through 22 on your own. You have a couple of freebies that are already finished and free points for you. And then in the review section, you have a much smaller required number of problems. A couple of things with the review section. You do not have to do all the problems. If you do problems that are not assigned to you, those will just be credited for extra credit. So a number 1 is not assigned, but if you want to do number 1 and you want to get some extra credit points, go ahead and I will just count that as an extra credit point for you. But I will go ahead and solve just 2 problems for you. I'm going to do number 12. Number 12 is a division problem of fractions, so really not related to the concepts that we covered today, but I want to just do a quick little refresher. So when we talk about multiplying or dividing fractions, we do not have to have a like denominator. You only have to have a like denominator when you're adding or subtracting fractions. But with division, you do have to do something sort of special, and that's take the reciprocal, which means essentially you're going to flip the second fraction upside down, and then you're going to turn it into a multiplication problem. So I'm going to still use my raised dot again just to get into the habit. And I'm going to take the reciprocal of our second fraction, which just means I'm going to flip it upside down, turn it into a multiplication problem. Then I want to reduce these fractions so 2 can be divided by 2 one time, 4 can be divided by 2 two times, so I can do a reduction there. And then 3 can be divided by 3 one time, and 15 can be divided by 3 5 times. So I've just reduced. I can now cross multiply. 1 times 5 is 5. 1 times 2 is 2, and my final answer is 5/2. If you have questions with that problem, definitely let me know. That's something that you should probably understand pretty easily. The last one I'm going to do for you today is number 14. It says round each number as directed. The number that they give us is 0.38 or 782. And in order to be able to solve this problem, which it says round out to the hundredths, H-U-N, and I'm just going to abbreviate hun, but I'm going to put driths at the end so that we understand it's to the right of the decimal. This is our tenths place, T-E-N-T-H-S, and this is the hundredths place right here. This is the hundredths place. And in order to be able to round to it, I have to look at 1 over from that position. And the rule is if it's 4 or down, it stays the same. I don't have to change much. I just have to cut my number off. If it's 5 or up, I'm going to increase, I-N-C-R-E-A-S-E, the value in the place that I'm trying to round to. In this case, it's an 8. So that means I'm going to increase the number in the hundredths place, which means my final answer is 0.38. And that is my final answer for number 14. So there are some problems that are solved for you. Hopefully I gave you a very flash, quick introduction, chapter 1, section 1. If you have any questions, put a discussion post out there for your peers or send me an email directly and I can be on board to sort of help solve some of those problems for you. Thanks for paying attention. I'll see you later on this week with lessons 1.2, 3, and 4. Bye.